Welcome to question 6, which is about circles for the beginning part and then moves on to gradient and tangent things near the end. So we'll start off with question A, which is a circle question that you'll see in one shape or another in probably every Core 1 exam that you do. They'll either give you the centre and the radius and tell you to put it like this, or they'll give you this and ask you what's the circle and what's the centre rather, and what's the radius. So how can we do that? Well, A here, A is going to be our x coordinate of the centre, and then B here is going to be the y coordinate, and K is going to be this, the radius squared. So the radius squared is going to be K. So let's write that down a little bit larger. So we have x minus 3, so plus 3 all squared. Then we have plus y minus 1 all squared, because it comes from here, and then that's going to be equal to root 13 squared, which is 13. So k is going to be 13. That's all we need to do for the 2 marks, and like I say, you'll see that in almost every Core 1 question in some shape or another. So then, hence find it in this form. So we just need to take this, what we've just got, and basically times out the brackets and take the 13 back over to this side to get a 0 on the end. So let's do that. Let's have x plus 3 expanded, x plus 3. So what are we going to get there? We're going to get x squared to start off, then we're going to get plus 3x plus another 3x, so plus 6x, and 3 times 3 is going to be a plus 9. And we'll do exactly the same thing for the next bracket. We have y minus 1 and y minus 1 again. So we're going to get y squared minus a y minus another 1, so minus 2y. Then minus 1 times minus 1 is plus 1. So let's write out what we have so far then in this order that we have here. So we're going to have an x squared plus y squared, then plus 6x we got from here, and then we're going to have a minus 2y we got from there. And then what do we have? Well, we have this plus 10 here, the 9 and the 1, plus 10, but then we have to take away 13 from both sides. So we're actually going to get a minus 3, which is equal to 0. So p there, our p, is going to be equal to minus 3. And that is for those 3 marks, which doesn't seem like a lot of work for 3 marks. So the next question, the circle cuts the y-axis at these 2 random points A and B. Well, not random, but arbitrary points A and B. And we need to find the distance between those 2 points that the circle cuts the y-axis at. So if we think about the y-axis, it's just a straight vertical line. So all the way along there, x is equal to 0. So our 2 points A, B are going to be 0 something and 0 something for another one as well. So how do we find that? Well, if x is 0, let's put x equals 0 into this equation that we just found, or the one at the top, it doesn't matter which, but you know, just out of a random choice, let's take this purple one and put x equals 0 into there. So we're going to get y squared minus 2y minus 3 equals 0. So that's just a quadratic. We do what we always would do with a quadratic. And I know you normally have x's in there, but you can do it with any letter. It doesn't really matter what letter it is. It doesn't really change. So we're going to get a y minus 3 and a y plus 1 in there. It's equal to 0, which means that y is equal to 3 and y is equal to minus 1. So what are we going to do then? Well, we have our 3, we have our minus 1, so let's put that in there, 3 and minus 1. Then we need the distance between this straight line, 0, minus 1 and 0, 3. Well, the difference there is 4 units. So the distance AB is equal to 4. That's just a straight line, the straight distance. Let's move on to question C. Verify that this point D, verify that it lies on the circle. So the way that we do that is by simply putting the x coordinate where x is and the y coordinate where y is for all of this equation, or the first one, or the one that we got given right at the beginning, or we worked out right at the beginning. So because it's here, let's just do this one. So we have minus 5 squared, 25. We have y squared, which is going to be plus 4. Then we're going to have 6 times by minus 5, so minus 30. Minus 2 times minus 2 is plus 4. Minus 3 doesn't change, and 0 doesn't change. So then we need to make it kind of really painfully obvious to whoever's marking this that this does indeed equal 0. So the way that I do that is by saying we have 25 plus 4, which is 33, and then we have a minus 30 and a minus 3. Minus 33 is equal to 0. I don't know how you can make it more obvious than that. If someone knows of a way, please leave a comment and I will look at it. And then for the second mark there, we have to say, or actually just for the mark there, we have to say therefore D lies on the circle. Yeah, if you don't write that, then you run the risk of losing the mark there, because some questions they demand you have that statement, some they don't. If you want to look up the mark scheme for this one, you can do, but I'm going to move on. I'm going to move down as well so that we have some more space here. So find the gradient of the line CD. Well, if you remember our point earlier, point C, which was, let me go back up. Point C is minus 3, 1. So let me write that down. So C is minus 3, 1, and point D, which we know is minus 5, minus 2. And we need to know the gradient between these 2 points. So how do we do that? Well, it's just how we would do the gradient anytime. It's change in y over change in x. So what's the difference here between these two y points, 1 and minus 2? Well, I think that's 3. The change in y is 3, and change in x between minus 3 and minus 5, well, that's going to be a difference of 2. So that is our gradient. That is our gradient of CD. CD is 3 over 2, and then hence find an equation of the tangent. So if we think about what we've done, let me go down and draw this out. So we have, our axis somewhere like this, and then we have our circle. What we've done so far, in black, is we have the center here, and then we have D, which is somewhere on this circle, somewhere there. So then we've got a line that goes through there, and what we've done is found that the gradient of this line is 3 over 2. What we want now, say that this is point D, what we need now is, I'm not going to use green, I'm going to use blue again. What we want now is a tangent line there. So the gradient of this line is going to be kind of the perpendicular gradient to this one. So how do we do that? Well, if we say that the gradient is m, so we say that this is equal to m, then we go minus 1 over m. That's going to be our new gradient. That's our new gradient, or the gradient of the tangent line, to use the proper terminology. So how do we do that? Well, put the 3 over 2 where m is, or alternatively, put a minus on the front and flip these two around, so that we're going to get minus 2 over 3. That's how I learned it. Put a minus on the front and flip it over, or put 3 over 2 down there and do the algebra. So we have our new gradient, we have our point D. We are ready to go with, move down a bit, y minus y1 is equal to mx minus x1. And notice up in the question here, they haven't said leave it in a specific form. They've just said find the equation. So that's what we're going to do. We're just going to find the equation. So let's plug in some numbers and see what we can come up with. We've got y is going to stay the same, and then y1 is going to be our y coordinate for D, so minus minus 2 is plus 2, is equal our new gradient, m, our new gradient, minus 2 over 3, then x minus minus 5 plus 5, and actually if we just leave it like that we'll get all the marks, but just for kicks let's go through and sort it out a little bit. We've got y plus 2 is going to be equal to minus 2x over 3 minus 10 over 3, and then what I would do is take away 2 from both sides and leave it like that, but I just got reminded that this video is quite long already, so I'll leave you with that. See you on the next video.